In this example, I want to talk about how we might find the binomial expansion of an expression like this one given here. And one way you might go about this is by writing this as 5x plus 4 multiplied by 1 minus x to the power of minus 1 multiplied by 2 plus x to the power of minus 1. And then you could find the binomial expansion of each of these terms, and then you'd multiply out to get the first three terms. But multiplying out three different expressions can get quite complicated and lead to errors. So approaching this using partial fractions is possibly a better way to go. So the first thing we would like to do is express this in partial fractions. And we know the form we are interested in is that 5x plus 4 over 1 minus x, 2 plus x is identical to a over 1 minus x plus b over 2 plus x. And writing this with a common denominator, this is a lots of 2 plus x plus b lots of 1 minus x all over 1 minus x, 2 plus x. And then because this is an identity and is true for all x, our numerators must also be identical. So we have 5x plus 4 is identical to a lots of 2 plus x plus b lots of 1 minus x. And then just selecting sensible values of x. If you let x equal negative 2, we get negative 10 plus 4, which is negative 6, is equal to 0 plus 1 subtract negative 2, which is 3, so 3b. So this gives us b is equal to negative 2. And if we let x equal 1, we get 5 times 1 plus 4 is 9, is equal to 3a, and then 1 minus 1 is 0, so we get that a is equal to 3. So our partial fractions are 5x plus 4 over 1 minus x, 2 plus x is identical to 3 over 1 minus x minus 2 over 2 plus x. And now we can use binomial expansion. Notice this is a bit easier because before we were going to have to do a lot of multiplying, whereas now we're just going to have to add together two things. So what is this equal to? Well, this is equal to 3 lots of 1 minus x to the power of minus 1 minus 2 lots of 2 plus x to the power of minus 1. Well, if we do our binomial expansions just to the side, the binomial expansion of 1 minus x to the minus 1 is equal to 1 plus n, which is minus 1, times by minus x, plus n minus 1 over 2 factorial, times by minus x squared, plus n minus 1, n minus 2 over 3 factorial, times by minus x cubed, plus some higher order terms, which simplifies to be 1 plus x squared plus x cubed plus the higher order terms. And our second binomial expansion is 2 plus x to the minus 1. Well, notice, let's firstly take a factor of 2. So this is open brackets 2, 1 plus x over 2, close both the brackets to the minus 1, which is 2 to the minus 1, 1 plus x over 2 to the minus 1. 2 to the minus 1 is a half, so this is equal to a half, lots of 1 plus n is minus 1, lots of x over 2, plus n minus 1 over 2 factorial, lots of x squared x over 2 all squared plus minus 1 minus 2 minus 3 over 3 factorial, lots of x over 2 all cubed plus the higher order terms, which is a half of 1 minus x over 2 plus x squared over 4 minus x cubed over 8 plus the remaining terms. So we can substitute both of these into here. So what do we get? Well, we get 3 lots of 1 plus x squared plus x cubed plus higher order terms. Subtract 2 lots of a half of 1 minus x over 2 plus x squared over 4 minus x cubed over 8. And now it is just a matter of collecting like terms. So let's do this step by step. It's 3 plus 3x plus 3x squared plus 3x cubed. 2 times a half is 1, but we have a minus here, so this is minus 1 plus x over 2 minus x squared over 4 plus x cubed over 8 plus higher order terms, which is then equal to 2 plus 7 over 2x plus 11 over 4 x squared plus 25 over 8 x cubed plus higher order terms. And that is our binomial expansion for this expression here. And it doesn't ask us for this, but let's just state where this is valid. Well, this binomial expansion is valid when x is between -1 and 1. And this binomial expansion here is valid when x over 2 is between -1 and 1, i.e. x is between -2 and 2. But we need to pick the strictest criteria here because both need to be valid. And the strictest criteria is x is between -1 and 1. So we can state that this binomial expansion is valid when x is between -1 and 1.